Bonjour, Madame and Monsieur. My name is Perry Krug. I'm one of the principal architects here at Couchbase and want to talk with you today about the topic of moving from SQL or really relational databases to no SQL, or really not only SQL, the non-relational and specifically Couchbase. So just a quick pass through the agenda. First, talk about why are we having this conversation at all. Talk about some of the specific use cases. Really focus on the data model differences, which is the biggest challenge when moving from relational to non-relational. Talk about some strategies for moving the data itself when you have to. Talk about what it means to move the application and some of the challenges to deal with there, and then touch on some of the clustering and scaling similar to what you just saw with Francois. So at a very high level, why are we even here today? Why no SQL? And many people will tell you many things about that. I think it boils down to, and we've distilled it down to really two key elements. One, on the application development and data side, the ability to develop with agility. And this talks about reducing or removing the rigid schemas that relational databases have imposed on us over the last 30 years or so. This introduces the idea of agile and iterative development, being able to add features, being able to evolve your data model, being able to quickly respond to changes in your marketplace, or quickly respond to requests from management for reports. And that's the development and developing with agility side. On the other side is very much a requirement to be able to operate the database, the data layer. And this includes all of the conversations around performance, scale, scaling out, replicating across data centers, maintaining high availability, performing upgrades while the system is running live, all of that on the operations side. And we have a very clear picture of what dev and DevOps really means here. And if we take a look at Couchbase, we've really structured our technology and our roadmap and vision around these two concepts. And we have a variety of features on both sides, be it our native JSON support, be it the use of our Nickel query language. On the operations side, our integrated and managed caching layer, the ability to elastically scale out a cluster, the ability to replicate to multiple clusters around the world. All of those dev and ops features come together to really meet the needs of what NoSQL is meant to provide. And we believe pretty strongly that Couchbase is the only, or one of the only NoSQL technologies that can provide both of these together. There's lots of technologies out there that are very easy to develop with, very flexible to work with the data. There are other technologies that are very easy to scale or can scale very, very far. I think there's relatively few technologies that can do both, and can do both in a reliable, performant way for a mission-critical application. And as I hope you've seen today, some of our key customers in France and around the world have been able to bear this out. Okay, so let's take a quick look at where Couchbase fits in the architecture, and this is really the beginning of the conversation of where might you look to replace an existing system with NoSQL or with Couchbase. In the broader umbrella of big data, we really see a clear distinction between the online and the offline world, or the real-time and the batch-oriented world, the OLTP and the OLAP world. And Couchbase and most NoSQL technologies really firmly sitting on the operational side, on the real-time interactive applications serving users, with technologies like Hadoop and to some degree Spark, the other types of data warehouses like like Teradata, sitting really more on the analytics side, batch processing, much longer running computational analysis, and the architecture of these systems is very different. The requirements that they're trying to provide, the applications that they're trying to serve are very different, and in many cases, most of our customers have some degree of both, have an operational data store and an analytics. And there's varying gray areas in between, but it helps to separate those two to understand where Couchbase really fits. We also like to talk about the kind of the new evolution of data management architecture, all the way from the top of your data access, where you're actually presenting data, the management layer in the middle, integration, and where all that data is coming from. And if we break this out into some specific technologies, you start to get a feel for what technologies fit at different layers. And this is a very realistic picture of many of our customers using Couchbase in that middle layer as the both caching layer and data serving, the presentation layer. Also down there in the corner for gathering data from mobile applications, serving some of the web and e-commerce. But you see, we're not in the data lake, and we're not in the data warehouse sections. And those are very critical parts of anybody's overall application, but it's important to choose the right technology for the best job that it's going to fit. And leading right into the next discussion, we'll take just a couple minutes and talk about where NoSQL, where Couchbase is a good fit, where it isn't such a good fit. One of the things I think we do very well at Couchbase is talk about where Couchbase is not a good choice. We don't want you or us to spend time on something that's not going to be successful, that's not a good fit for Couchbase. We like to take a very honest approach to our customers. And in the same respect, when we say that Couchbase is good for something, we feel very confident that it's going to be able to live up to those claims, that we have other customers doing some of the similar things. And so there on the left, the web, mobile, IoT applications that our CEO Bob talked about earlier today, looking at latency criticality, the throughput, the numbers of users that need to consume the data that you're serving, the ability to scale out. Sometimes unknown demand comes in spikes, the ability for the system to absorb that or scale out to handle it. Looking at the other side, some of the more legacy business applications, the back office, very transaction heavy on legacy hardware. All of these sort of things tend to, although not exclusively, tend to mean that, well, if they're working today, why do we need to change them? NoSQL is about meeting the requirements, the new requirements of new applications. And so when we start to talk about some of the specific use cases, many of which you've heard about today, talking about public profile and catalog management for streaming media, for user profile stores, looking at the personalization requirements like Criteo, providing personalized ads for their traffic. Looking at 360 customer views, bringing all of the data for a particular customer together into one place. IoT and mobile, obviously, are good fits here. So I'm going to stop now with kind of the high-level introduction to things, just get a sense of where Couchbase and NoSQL fit, and let's take a deeper dive into what it means to translate both your mind, your data, and your application to NoSQL. So first we're going to take a look at data models, and I think some of this is going to be very obvious to you, or at least clear in your minds, and I'll try to go through it in a quick fashion. But Couchbase, as you know, is a document database. We're not talking about PDF and Word and PowerPoint documents here. We're talking about the structure of how the data is stored in Couchbase. And comparing that to the relational model of rows and tables, where your data is very, very heavily normalized, split out from an application object into many rows or many tables within your database. Couchbase focuses on some degree of denormalization. We're going to talk about this a little bit more, and I hesitate to say exclusively just denormalization, because Couchbase has some unique capabilities to give you both normalization and denormalization. I'm going to talk about that more. But basically the idea of taking the application object, the way that your application is working with data, and storing that directly in the database. And when you want to retrieve that data, pulling it out of the database in as close to the application object structure as possible. And sometimes that's easier when you just have a direct key value or primary key access to the one object that you're trying to get. Sometimes that's a little more complicated when you have to aggregate data from a couple different objects or a couple different documents to build up that object. But it all works in the JSON object model. Here's an extremely ugly picture of what probably many of your applications look like today. I won't point out anybody, but I know you're out there. And it's this kind of picture that creates the challenges and the problems for organizations today to add features, to add capabilities, to put data in here that doesn't quite conform to this mess of tables and schema. If we take a simple example, a user profile store, we may have just 2 tables. And I know none of you have applications with just 2 tables, but I had to fit them on the screen here. We're going to take the user info, and we're going to join it with their address info. This multiplies exponentially as you go to different data structures and schemas. But when we look at storing the same data in a document, you might just have one document per row or per record per object with all of the relevant information stored in there. So in this case, we're storing a combination of 2 tables into one. And this is an example of denormalizing your data, taking 2 tables and combining them down into one. We're going to see a little later on of where you might not want to take this approach with No SQL, but the same kind of concept will still apply. As we want to make a change to that relatively simple model, we're going to add a few tables, and maybe we've already got the joins and the foreign key relationships set up here, but then we want to add a new table to that. We're going to go through and we have to edit and alter table to every single table that we have. We have to add an index. A few thousand rows, this is not going to be a problem. A few million rows, it might take a little while. A few 100 million or a few billion rows basically means you're offline until this is done, or you're going through the incredibly painful Saturday night, Sunday migrations, either with downtime or with juggling back and forth between multiple systems. At a very simple level, when we think about making the same change in a document database, it's just as simple as editing the one document that you want to add that change to. So we may have millions or billions of user profiles in here, and it may be Dipti, who's the only one that has supplied us with geolocation data, so we just put that in her user profile document. We don't care about the other ones. The other ones still stay the same. There's no need to go and edit all of the other documents. When your application reads this, it's able to identify, oh, this document has some geolocation. Now I can use that in my application to expose to Dipti's user. When you read Perry's document and I don't have geolocation data in there, that's okay. We just keep moving on and don't show that feature. These very simple examples would start to give you an idea of how you can very easily have data sitting side by side with each other with different styles to it or different records in it, even though they're all part of the same general document type. Some of the high-level benefits of this model, we talk a lot about the impedance mismatch between an application and its database. Applications using relational databases have to go through an ORM layer, breaking out their objects into rows and tables, and then joining that back together and pulling it back into the application. With a document model, the way that the data is structured, the way that the data is put together more closely resembles the application object model. Doesn't have to be exact, but resembling it more closely. Generally, it means you can write to one place. You're not writing to multiple tables. This has lots of benefit when we start talking about transactions and locking. It means that I can write a user profile over here and another user profile over here at the same time, and I didn't have to lock the user profile database because they're separate documents. The user profile table. The relaxation of schema, I think, is something that everybody is looking for and hoping to take advantage of. The ability to store data side by side of different types, of varying types, of changing types. Could be that same user profile type of data with 99% of the same fields, but as I want to evolve my application, as I want to add new features, new capabilities, I need to start adding more data. I can do that on an incremental basis instead of a one big shot. This doesn't mean that it's schema-free. I dislike the schema-free, schema-less notions. It means that there's not just ones and zeros and twos and threes flying all over the place in your database. The data still has a structure, but it's a structure that the application is in control of. It's a structure that the application can manage, and the database is just sitting there taking and serving up the data the application is asking for, which gives you a lot more flexibility in code to change and augment that. Some of the challenges, it's new. This is new stuff, right? Couchbase has been around 6 years. Mongo's been around about 7 years. Object databases have been around for a while, but people stopped using them when they found Oracle and DB2. So this is a new mind shift. And this means that it's going to take you some time to figure out where the right fit is, what the benefits of it are. Is it right for me? But I think that when you are able to identify the right application, the right benefits that this document model brings you, you're going to see a lot of the benefits for where it fits. There is definitely a tighter coupling from the application to the database. And I don't think we're going to get away from that anytime soon. There are layers being introduced and object document mappers, but at the end of the day, your application developers are going to have to know how their data is structured in the database, because that's going to directly influence how they're able to get it out into their application. It's the DevOps world. Sometimes this can be painful for some customers. Sometimes this can be a smooth transition, but there is definitely that tighter coupling. I talked about, or I haven't really talked much about relaxed consistency. I won't say eventual consistency, because Couchbase we don't consider ourselves eventually consistent. We consider ourselves giving you a relaxed consistency, the ability to trade off strong consistency when you need it, but also to have better performance by letting things happen asynchronously. And so for our individual document reads and writes are always strongly consistent. If you write something and you read it right back again, it's always going to have what was last written to it. As that flows through the system, and we've seen various talks about our architecture, as that flows through into our indexing and querying, you have the ability to maintain strong consistency, saying I want this data to be ensured for it to be in the index, or I want to get my answer a little bit faster, and I'm willing to know and understand that there may be data changing at a higher rate, and that will eventually be there when I come back around to query it. And these are not decisions that I can give you a black and white 1 and 0 answer to. These are just part of understanding how your application needs to and can best interact with the database. And one thing I do want to point out, especially with Couchbase, and this isn't true with all of the other No SQL technologies, neither Mongo nor Cassandra really provide this. We like to see a sliding scale or a hybrid of denormalization and normalization. And as I mentioned before, normalization being splitting out data into various tables and linking them together, denormalization bringing that together. Now, denormalization generally has higher performance, but comes with the challenge of duplicate data. And in many cases, you don't want to duplicate your data. And so with Couchbase, you can choose on a per application, per document, per data type way to either denormalize fully or to some degree, or to normalize a bit of that where it makes sense. And later on, I'm going to show you really what I mean by that. But I think it's an important concept because No SQL in general has really pushed this idea of strong denormalization. And I don't think that that's appropriate for everybody. The duplication of data, the way that changes your application to work with data, I don't think we need to go from only normalized to only denormalized. And Couchbase allows you to sit somewhere in the middle based upon what your requirements are. And I'm going to talk about joins a little bit later in the session. How am I on time? Okay, so Let's talk quickly about migrating your data. This is going to be how do you translate from a kind of relational model into a non-relational model. That may prove useful for some of you, but I have to say that in most cases you're going to be better benefited by starting from scratch. By starting with a greenfield application or a greenfield layer written on top of what you already have or on the side of what you already have. The data models, no matter what we do not translate generically. There may be cases where I can take, and I'll go through this, there may be cases where I can take every table and make it a document type, and take every row in every table and make that its own individual document, and take every column and make that its own JSON field. But that just doesn't always bear out. And it may be useful for doing that just to test or export your data and move it so that you can start getting into NoSQL. But I would really caution you not to say, all of my Oracle tables just become documents in Couchbase and I'm all set. It's not going to benefit you, and it's not going to benefit us. So as I mentioned before, that sliding bar of denormalization versus normalization is probably the biggest factor that's going to control how you migrate a complex table schema into a hopefully simplified document model. As talking about some of those points, one type of document may very well be a combination of multiple tables. We're going to look at that in a second. And your concurrency requirements may choose or may force you to decide to break things apart into different documents. And so if you know there are certain types of data that needs to be read or especially written very heavily. There are things you can do in Couchbase to avoid any sort of contention or concurrency problems on that data. So the same sort of challenges that you would have had with locking a table in a relational database, by changing your data model, by changing your document model, you can get away from any sort of concurrency and really get the benefit of parallelism across multiple nodes. But that's not going to always be the case if you just do a very straight translation of table to document, row to document. An example of that, again, going back to that user profile idea, if we had 3 different tables here that are all linked together in a relational database, they all come together into one document. And this makes a lot of sense. This Javier Hernandez, he has these skills, this is his experience, and this is his role. Now, if we, I don't have enough graphics for it, but if we expand our mind a little bit and think, well, that Couchbase company in the table, that's going to point to another table and have all the information about Couchbase, our address, our telephone number, maybe our number of employees. That would not make any sense to put into this document, right? Because every employee of Couchbase is going to have all of the information of Couchbase in every one of their documents. That doesn't make any sense. You're going to have to change every single document every time you change Couchbase's phone number or address. That's the danger of fully denormalizing data. And so in this case, we would say, yes, we want to denormalize these 3 tables because that makes sense for one user. But we want to normalize and have a separate type of document for a company. And this company :Couchbase field would be a reference to that document. And that document would contain all the information about Couchbase. It's all in one place. When we change our address or our telephone number, it gets changed consistently for everybody that is referencing back to it. And with Nickel, and we're going to see in a minute, with Nickel we can do that in one statement. We can do a join across these different documents, or you could do it manually in your application by knowing which different documents to pull together. So that's an example of where sometimes it makes sense to normalize and sometimes it makes sense to denormalize. And unfortunately, I can't look at a relational schema and tell you this is how it should translate. And nobody can tell you how to do that because it's the characteristics of that application, the characteristics of how that data means something in the application that really controls what those decisions are. So before I get a little bit deeper into the application side of things, if you do want to move the data, and in many cases it does make sense either temporarily or on an ongoing basis to move the data from a relational system to Couchbase or a NoSQL system, there are generally kind of 3 ways to do it, either online with a constant real-time flow of data, with a repeated batch load, or with a export and import, kind of a one-time thing. If we look at very simply moving the data online, these next 3 pictures are all pictures of our actual customers and their architecture, of ways that they've gone about moving over to Couchbase. A very common, very simple way is to use Couchbase as either a cache or a look-aside aggregation layer, and your application is the one that knows how to translate from one to another. And so as a request comes in from your users, the application knows, let me first look into Couchbase and see if the data is there. If it's not there, I'm going to go get it from Oracle or DB2 or whatever and put it into Couchbase. And then the next time that same request comes in, it's in Couchbase already. This is by all means certainly a caching way of using Couchbase, but over time you have less and less and less load on the Oracle database to the point where you don't have any requests going to it, and now Couchbase is your system of record. Viber, one of our customers out of Israel, went through a very similar migration from their pre-existing database over to Couchbase. They wrote their application so that they could continue serving users as they migrated from one to another. This works in many relatively simple cases. It requires a little bit more application logic, but it does give you much more flexibility, much more control over how and when you access each one of these systems. If we take a look from doing this in a batch process, again, continuously getting the data in, but it's not quite real time. This comes from Tesco up in the UK. They did not want to write the application to know about the Oracle cluster. So they wrote an application that only knew that Couchbase was there and was only able to operate off the data in Couchbase, but then periodically exported data from Oracle and dumped it into Couchbase. And they had to do this a bit of ETL process where they took CSV out of Oracle. They rewrote that into JSON and munged the data, adapted it a little bit, and wrote it into Couchbase so that the application could use it. They had the requirement of still needing to serve data off of that Oracle database from other applications that they did not have control of. If we look back to this one, generally if you have control over the whole application, you can control all of its access and you can know this request is going to go to Oracle, this one's going to go to Couchbase. If you know there are other parts of your business, other applications that need to be accessing the data, both reading and writing it, and you don't have control over them, then this is a good approach to write your own service layer and slowly migrate users onto your service layer, taking them away from or deprecating the old applications. And finally, if you were in this session a few sessions ago, there's a growing kind of transition from that batch world to a streaming movement of data. And Spark, Kafka, Storm are very popular technologies to do this. Again, writing an application to talk directly to Couchbase on this side, it's over here for me, but on this side for you, and then using Spark or these technologies to manage the synchronization so that as changes come in, Spark is responsible for persisting them into both databases in their varying formats. As requests come in, those requests can either go directly to Couchbase because that's where the data for those applications lives, or can come into Spark, and Spark would be able to do that aggregation and translation again. So these are just 3 very high-level kind of architectures, depending again on what your requirements are and what your application is trying to do. All right, next let's talk a little bit about what it means to migrate the actual application. And no matter what as I mentioned earlier, we see the most adoption of Couchbase, the most benefit being had by greenfield applications, by new layers, new services being developed. There's no getting around the fact that it's not going to be a drop-in replacement for Oracle. Our query language makes it easy to translate what you're trying to do with Oracle into what you're trying to do with Couchbase, but there's no way that this is going to be just rip one out and put the other in without any changes to your application. I'm going to try to go through this quickly. Francois earlier talked about the different access patterns, so whether it be key value or query or using our views, understanding your concurrency and consistency needs, concurrency being how many times am I updating the same record from various different processes, consistency being how tightly do I need a particular change to be present throughout the rest of the system. And being able to understand those and trade off will allow you to use the tools in different ways. Start small, start with something easy, start with something you're familiar with or you have a clear need for. If you're solving for performance, put Couchbase in as a caching layer. If you're solving for flexibility, take the data out and write a service on top of Couchbase that does not have all of the constraints and dependencies that your relational database has imposed upon you. So just in the interest of time, I'm going to skip through this because you saw it already for Nickel. I want to talk now just a little bit about a join because most NoSQL systems, and in fact Couchbase up until about a year ago, didn't really have the concept of a server-side join or a database join. And if we look at this data model, slightly different than I was using before, but we have one customer document and we have multiple purchase orders or purchase documents. And you can imagine as someone is making orders, we're creating a new purchase document for each time they submit an order. And that second line in each of the purchases document is the critical part here. That customer ID is the primary key of our customer document over here. And coming from a relational world, it's very easy to understand that that is the foreign key that's pointing into a different table. So this is the purchases table with a list of purchases and a foreign key pointing over to the customer table with the other information. And we're going to, with this one nickel statement, it looks a lot like SQL, doesn't it? This one nickel statement, join those two together. And so we're saying select the email address and account of the purchases from the purchases table joined with the customers table using this key, this field as the foreign key. And so you can specify any of them. This can be chained, multiple joins down the line, and then grouped by the email address. And what Nickel is going to do, what our query engine is going to do, is start reading the customer documents, start reading the purchase documents, and it's going to identify that second field in there as your foreign key. It's going to go and reach out for the customer document. It's going to pull out the information that you asked for from the customer document, the information or counting or grouping that you asked for from the purchases, and return to you, the application, the answer that you've asked for. And this is just one example and a very simple example of the power that joins bring, having been built into really as a first-class citizen from the Couchbase language. If we look at Cassandra's CQL, they really have no concept of joins. If we look at Mongo, not even a language, but the lookup concept gives you some capability to translate between or to join different documents, but it's much slower based on their aggregation framework and whatnot. Joins were a key part of how we developed the language from scratch, based upon similar mathematical and algebraic concepts as SQL was, to allow you to compose your question and allow you to get the best out of a schema-free, or I used it myself, a relaxed schema data model. So using some denormalization in our customer document, but using normalization for our purchases to refer back to that. So just I have a few more minutes. Some of the other things to take into account, joins, as I mentioned, a big part of relational database modeling, a big part of Couchbase modeling, and something that we believe really sets Couchbase apart in its ability to do that. Stored procedures and triggers. At a very simple level, we don't, and really most NoSQL databases don't really have much support for that. A lot of that logic tends to move into your application when you're deciding what to do as data changes. We've got some features on the roadmap that will be kind of enhancing that capability as well. BI and analytics is that kind of fuzzy area between OLTP and OLAP. Nickel provides some really great reporting for operational analytics, for reporting on what the data in Couchbase is doing and how it's looking. But we're not trying to be, at the moment, not trying to be an analytics database. And so just understanding where that boundary line is for your application. We integrate very closely with Hadoop and Spark and Kafka so that you can combine multiple systems for the needs of one broader application. And we do support, as Francois just showed you, ODBC and JDBC out of the box on top of Nickel. So for Tableau, for ClickView, for Power BI, if you want to create reports off of the data that's in Couchbase, you absolutely can do that. Transactions. So transactions is the one sticking point for everybody, and they think that they can't use NoSQL because they have transactions in their relational database. And that's not really true. So relational databases do have support for transactions. They have great support for transactions. They have such support for transactions because they need it. Because of the way the data model is split out across many different tables, and you have to update things in such a tightly coupled and consistent way. And it's not always a good thing for concurrency, for performance, for scale. You can't have transactions across multiple nodes of a relational database. And so historically, Couchbase and NoSQL really have kind of eschewed the idea of open transaction, do a bunch of operations, and close transaction, because it just doesn't make sense in a distributed world. What we find is it's not as necessary either. Because you have done a bunch of denormalization where it makes sense, every write to an individual document is a transaction. Every write in Couchbase is ACID. It's atomic, it's consistent, it's independent, and it can be durable if you want it to be, or you can trade that off. But we don't have transactions across documents. In many cases, one document might be on one node, another document might be on another node. We don't want to have any deadlocks or contention across them. And so your data model should take that into account. Where it makes sense, you can treat one write to one document as a transaction. And if you do need, and there are a few cases where we need to have cross-document atomic and consistent writes, we have a couple customers that have implemented their own kind of two-phase commit logic up in the application, and that works well enough. It is a trade-off of performance because you're doing more back and forth to the cluster, but it gives you the benefits of that. And I think you will see, and I don't want to speak for Ravi in the room here, but I think you will see Couchbase developing more and more capabilities around that in the coming years. It's not something we have anything specific on, but we certainly recognize the need for that ability to do so, and want to find the right way of providing it to our customers without just saying, yes, we do transactions, because that may not be the right answer anyway. How am I on time? Am I out? 2 minutes? Okay. I'll go through this stuff pretty quickly because Francois covered it earlier. I spent most of the time today talking about the data model, your application, flexibility of data. A very equal part of NoSQL is the need for performance and scale. And Couchbase gets that from our clustering and architecture. And so you saw this one from Francois. Our single node, every node in Couchbase is the same. It has the capability of running all of the same logic and the same workload. A single node operates the same as 100 nodes do with Couchbase. So if you have an application on your laptop and you're talking to just one Couchbase node, you can take that exact same application without any changes and point it at a 20 or 30 node cluster in the cloud, and it'll operate, behave exactly the same. Hopefully it performs better on a 30 node cluster. But that only comes from the fact that we have all of this capability built into one node, and then at runtime, you turn on or turn off different workloads for a particular node. And so if we think about, as Ravi said earlier in the keynote today, indexing, querying, data storage, these are all things that a database needs to do. And historically, databases, even relational databases, would do that across all of the nodes of their cluster. Every node would be expected to perform some level of indexing, some level of querying, some level of data storage. And you had to scale your system or provide hardware resources to the level of the lowest common denominator. So if you had immense query requirements, but relatively small amounts of data, you still needed immense amounts of CPU everywhere in order to support those queries. On the other hand, if you had large amounts of data that you wanted to store, but relatively small query workload, you had to scale the system and provide resources just to do that data storage without taking the two into account. So what Couchbase did back in 4.0, we introduced this idea of multidimensional scaling. And this is the recognition that these services and these workloads are different within a database and should be treated differently and may very well want to be scaled differently. And so you can continue to deploy Couchbase like this, and a single node has all the services running on it. 3 nodes of a cluster all have the services running on it. This will scale out the same way that Couchbase has been doing. But as you start to put more and different workloads on Couchbase, you might want to say, you know, I need different hardware for different workloads and different services that my database is providing. And so you can very easily, hopefully very easily see that I might scale up my query and indexing. I might add more CPU to the query nodes. I might add more RAM to my indexing nodes. And I might scale out my data service. I need to store more data, but I don't need the same 64-core CPU and 128 gigabytes of RAM in my query and index service. I don't need that same capacity in my data service. And this works very, very well when we start to talk about the cloud, different instance types, different hardware capabilities, and the ability to dynamically and elastically scale any one of these layers without taking the whole cluster down. As Ravi had his picture up earlier, all of this is held together by one common cluster administration layer. This is all one cluster. It's all fronted by one programming and administration interface. So whether it be Nickel or our key value APIs, the application doesn't need to know whether there's 2 or 4 or 6 or 10 or 1 node in the cluster. We handle all of that transparently for you, and that's why, again, I can say you can be coding to 1 node on your laptop, and you can deploy it against this in the cloud without changing any of your behavior and characteristics. So, in summary, primarily decide why you might be adopting NoSQL. It's not just because it's cool. It's not just because I said so. Is your application, your current database, working for you? We don't need to change that. Do you have new requirements? Now it's time to think about, is it the best choice for me? Are you building something new on top of that? Can you build it as a new application, a new service, a new feature along the side or on top? And do you need data flexibility? Do you need better performance and scale, or do you need both? And I can talk for endless hours about customers that chose Couchbase just because of the performance and scale, customers that just chose Couchbase because of the flexibility that it provided, and customers who have needed both out of it and have found Couchbase to meet their needs. And then finally decide how you're going to adopt NoSQL once you've decided that you do need it. Do you need these systems to operate, your existing and your new system to operate side by side? Can they operate in isolation? Can you add a layer on top, either caching or aggregation from multiple other systems? And do you need the data to be imported, or can you start from scratch? And if you do need the data imported, do you really need all the data? Do you really need all your 7 years of history to get started providing a new service to your customers? Some of you may say yes, and some of you may say no, and these are the questions that I think you should be able to answer before you decide to rip out Oracle and put Couchbase in. So thank you very much, merci beaucoup, and I will be around as everybody later on if you have further questions. So thank you very much.